In this student scene, we're using the tools to select a menu item to start the scene. Switching the tool with the thumb pad allows us to choose the teleporting tool to move around the scene, and then their switching tool to allow them to collect a key. And later on in the scene, that key will allow them to open another door and go progress through the scene. So we're in the process of building that tool selector, and in this script we'll be looking at creating the pointer. In this video we're looking at the pointer system. All of my tools pretty much use that pointer system in some way to interact with the environment in the game. The pointer system itself, it's just an object that can be anywhere in the scene. This is mine here. It's just off to the side. It started as an empty game object, so I just did game object create empty. And then as a child object on that pointer, it has an object named line. You can name it whatever you want, line render, anything. The important thing is that on that child object, you add a component line render. And this is the thing that the component that actually draws the visible line. A couple of changes or settings that you want to take care of. Make sure that you leave it in world space. For positions, you don't need to set positions on this line. That's going to be done through scripting, but you want to set the width to 0.01 is what I've got it. That's a nice narrow line that you can use. Just for the purposes of just showing you, I can also set the color. So I'll just make it red for now, just so you can see it better. And what's doing is it's starting a solid red and fading out to white at this point. Don't worry too much about setting those colors the way you want, because we can do that in scripting quite easily. So we have a pointer, and we have a line on it, and there's also a pointer script attached to it, and that's the scripting that we're concentrating on today. And it touches on a bunch of other stuff too, but we're going to basically concentrate on the basic functionality of the pointer and the reticle. So you make a public class pointer, make sure the names match when you save them. Include the Unity Engine events namespace at the top. As the script opens, we're declaring a bunch of variables here. So the public float m distance, that's the default distance that our pointer is going to go out. And that's something that you can change. The line render is that line object that we created as a child of the pointer. There's a layer mask, everything mask, and a public layer mask, interactable mask. Oh, well, what the heck's a layer mask? Okay, so in Unity, in the physics, on any object, you can look at the top in the inspector, and there's a pop-up menu for tag, and there's a pop-up menu for layer. So these layers are for physics. They have nothing to do with the visibility of objects or what objects are in front of or behind objects. They're about what objects interact with each other. So for physics layers, in this particular project, we need to have an interactable layer, an everything layer, and a floor layer. And as you progress in the scene, you might decide you want other ones in there as well, but that's what I'm using. And if you want to add a layer, you just click add, and you get the menu to add the physics layers. And so basically, when you're doing things like raycasts, you can identify what objects are hit, or you can limit what objects are considered targetable or teleportable on by using these physics layers to identify them. So as long as you're aware of it when you're doing the scripting, we're talking about physics layers when we're doing these layer masks. we've got a public Unity action vector3 game object on pointer update. So basically this is another action, just like in player events where we created an on touchpad up, on touchpad down, on trigger pull, on trigger release. In the pointer script, we're creating one that's going to run and update information about the game object that we've targeted with the pointer. So when we run on pointer update, it's returning the position of and the name of the object that we're getting, that we are targeting. Public game object reticle, or reticle is a crosshair. So in my scene, just for scaling purposes, I've got my reticle up close to my view, to my camera, and to the pointer, so I could kind of compare it to the other sizes. That started as an empty game object, so I just did game object create empty, and I named it reticle. And there's a script on it, which we're going to get to in a minute. There's also a child object on it, and for me, that's a sprite renderer with this crosshair graphic. I went on the internet and I got a download pack of these cursors and crosshairs. And the one that I'm using for the default is this one, a crosshair 7, which has an opening in the center of it. This particular cursor pack is meant for high resolution games, and so if you just drag and drop one into the scene, they're huge. I've adjusted the pixels per unit on it to 2400, which for me, that's about right. I could make them even smaller, but this kind of makes them easy to see in the scene for the purpose of the demo. So the open crosshair is the one that you want as default. When you target an object that you can do something with, an interactable object, then we want it to switch over to crosshair 8. And that's what the Reticle script does. It does the switching of the crosshairs. So I have the open one as the default and the open sprite. Those are the same. And the close sprite, I'm using this one, crosshair 8, which is basically the same thing, but with a dot in the middle like you've targeted. So we've got pointer, we've got reticle. Let's have a deeper look at the pointer script now, so we know what the setup is on that. Okay, so we've got game object reticle. The next variables transform current object, private game object, current object. So these are basically setting up so that we can vary where our line starts, and so that we can keep track of what object we have targeted and where we have targeted in space. These next variables, these are custom variables that I've created for my different tools. For me, I use a gaze pointer when I'm interacting with menus. When I grab something with my grab tool, it keeps track of what object I've grabbed. It's targeting my weapon action script so I can change things. It's targeting the weapon object in order to get at the weapon action script. I've got a teleporter tool, I've got a grab hand tool, and there's an object attached to the hand where I want the things that I'm grabbing, where I want them to end up. And I've got a transform to be the default origin of things, of the line renders that I'm creating. All of these, I would suggest you might want to just leave them out or comment them out to begin with, and just get the basic functionality of the pointer script working first. So on void awake, what we want to do is now add in a delegate function for our on controller source, on touchpad down, on touchpad up, on trigger pull, on trigger release. So just a reminder what a delegate is. A delegate is when you make a base action, like on our player events, we did these public static Unity actions. By making them public static, that means that we have access to them for any other script. We just need to call them by their name. And by declaring them as null to begin with, we're setting it up so that in the pointer we can add on the functionality on the pointer script. through on controller source, on touchpad down, all of them, there's a plus equals to add a new function. Whatever you name them here, you just have to make sure that the name that you give the function in the script matches what the name that you've given it here. For me, I'm setting it up. I'm saying where my weapon action script is coming from. If you want to begin with, you can just comment that out. But basically, what I'm doing here is I'm declaring the weapon, and I'm declaring weapon actions in my declarations at the top. And on weapon actions in Awake, I'm saying that the weapon action script that I'm going to target is the one that's a component of on our weapon. This way of doing it, by declaring the object that has the script and making get component to target the other script, I have never had this fail. I'm setting it up so that when my lines start at a transform that I have control of, so I can manipulate the positioning of this shot origin object to say where my lines start. There's a gaze pointer that I'm using when I'm interacting with menus. So when you're doing a delegate system like this, when you've got player events on control source and you're adding in a function like player events on touchpad down plus equals process touchpad down, it's kind of like setting up an event listener system. If you've done JavaScript or you've done ActionScript, the listener function, the on touchpad down, is always going to be looking for process touchpad down. When our scene ends, if you stop the game, say you go to a game over, when the object that's running the pointer script is removed from action, we want that listener system to end. So we've got private void on controller source minus equals. So the base function is still there, but it's running on null rather than trying to run a delegate function. So that lets us have an event listener kind of system. Also takes care of removing the event listener when we're not using it. Private void start, I have nothing running on private void start. I'm just going to leave it. The end position for the line starts at our origin position, goes forward at the distance that we set at the minimum distance. If the hit collider exists, then the end position is our hit point. So what does that mean? It means if we are aiming our pointer and it hits a game object on the interactable layer, and that object has a collider, then the raycast will know where we have hit that object on that collider, and our line will end at that hit point, and the cursor and the reticle will show up at the hit point. Then it sets how long the line is. Well, when you do line render set position, 0 means the starting point. So 0, 0 is the order of the line position, and comma, and then the next one is setting the value of it. So our starting position is wherever we set our current origin is going to be. The line renderer set position 1 is the end position. And this script update line is returning the end position. So if you look at update, this first line is saying, where do you want the line to go? Where do you want it to start? Where do you want it to end? We're getting that from update line. List of private functions we've got going here. The next one is private raycast hit. So when we raycast out from our controller, we want to get information on anything that we hit with our raycast. And so when we set this up, we're telling it to return a raycast hit. So that class of information, it will give us the name of the game object that we hit, and we can use that name to find out if it has a tag or not. And that's the major part of a lot of the things that we're doing with the control. So private raycast hit, create a raycast, and it's targeting the specific layer, and it's a physics layer, and for most of our raycasts it's using interactable layer. So I'm setting up the type of ray that I want it to create. I'm setting up a new ray, starting at the origin and going forward. Using physics, I create that raycast out, and it's going to send back information about what it hits. It's going out a kind of standard distance, and it's only interacting with the layer that we tell it to. And it returns information about the hit in the form of a raycast hit, which allows us to find out the game object that we've hit. Next private function is private void set line color, and you can use this and you can create variations of it. I'm so far not using it too much. This comes from the VR with Andrew series, but I don't really use it. Okay, so the next one, private update origin. This one is basically identifying which controller we're using for input and what the object is in the game that's representing the controller. And we're setting the origin based on where the actual controller object is, if we haven't set it in our shot origin variable up at the top. If we have, it's using whatever we set as shot origin. And for me, I'm just turning off the line render. So this is different from VR with Andrew, just disabling it. And I'm activating it on later on in the Pointer script when I want it to be active and when I don't. Okay, private game object update pointer status. This is huge. This is important. Game, it's looking at the raycast towards the interactable mask. And so if it gets information back from that raycast, if it returns a collider, then if hit has a collider, it's going to return hit.collider.game object. So this update pointer status, the value that we are getting back from it is the name of the game object that we've hit with the raycast. If we haven't hit anything, then it returns nothing, returns null. And so all of those pieces working together, most of it on update. It's updating the line, it's updating pointer status, it's doing on pointer update to find out the hit point and what object we've hit, if there are anything. It's positioning the reticle according to the hit point, or it's just leaving it at the origin. So all of those private little functions here come into play when we are looking at the private voids for the delegates, process touchpad down, etc. When we're looking at these delegate functions here, process touchpad down, process touchpad up, process trigger pull, process trigger release, this is where we start pulling in information from weapon actions. And when we're looking at the controller for the touchpad, we want to get information from it when we click on it. But not only can we get it to tell us that it's been clicked, but we can also get it to tell us where we've touched the touchpad in an axis 2D. So the center of the touchpad is 0. Moving to the left, X is goes to -1. Moving to the right, X goes to +1. Going up, Y goes to +1. Going down, Y goes to -1. And so we can get the information about where the touchpad is touched by running a line like this. Vector2 touch equals OVR input get OVR input dot axis 2D dot primary touchpad. And then a comma, and then which controller are we getting this information from? We're getting it from our active controller. And you may not even need this section. It depends on the tools that you've chosen to add into your game. So just remember that all my options that I'm creating here, they're all based on being able to change the index of the weapon in the weapon action script. Okay. In my scene currently, I am not doing anything with process touchpad up, so I'm just returning. And then I'm doing private void process trigger pull. And what I want it to do is to play the sound. And the particular sound that I want it to play is the corresponding sound to the current weapon index. So if I say weapon actions.play sound, weapon actions.weapon sounds, so I'm not targeting the weapons array, I'm targeting the sounds array, but I'm using the index from the current weapon. So sound 0 matches current weapon index 0, provided you've set it up wrong. Okay. And then, so the rest of this process trigger pulled, it's relying on the indexes from weapon index to do the things that we want it to do. So I'm just going to kind of show you a template for this. This one is complete for my game, but it's not for yours. So basically what I did when I was setting this up is I'm checking the weapon action script, and I'm checking for its current index. And so when I started this out, I'm testing for current index 0. So that would be the start. Sorry, got a little typo in there. And so that's an empty one. So you can kind of, if you have 5 tools, you can just set up these ifs in advance and then go in and add them in after to do the things that you want them to do. So I go else if and weapon actions dot current weapon index equals 1, and then what do I want it to do for the next one? So you can create as many of those little templated else ifs for whatever kind of situation you want. You have 2 different tools, you have 4, you have 50. You can create as many different ones as you want there. So mine is already set up, so I don't want those, and we'll delete them now. But you kind of get the idea. You're creating a template there to fill with the different specific actions that you want. Okay, so for me, when my index is 0, I have a teleport system I want to activate. When it's 1, I've got a gaze pointer system to interact with menus and button kind of things in my scene. So that's index 2, or index 1, I should say. Index 2 is one of my laser weapons, and I have it drawing the line, but I'm making the line red, fading out to clear. It's finding out what object it hits, if any, and if it does, if it does, it compares the tag. If the hit object's tag is Scorpion Enemy, that's one of the little enemy robots in the scene, then it's going to go to a script on those enemies called enemy teleport, and it's going to make a variable hit equals true. Does the same thing on my other current weapon index, but it changes the sound. The sound sounds more powerful. And then for the last one, this is my grab. So it's drawing the line render, but it's making it blue instead. Checking to see if the object that we've hit has a title comparable, and then it's going through a process for the grabbing part. And then there's a similar setup for the release, process trigger release. So again, I'm testing for the index. If it's a teleport one, it's doing the actual teleporting. If it's the gaze pointer, then I'm just turning it off. If it's the lasers, then the line render gets turned off to end the shot from the laser. If it's the grab one, then it's playing around with gravity and kinematic, and it's basically doing the throw. That's when you release, it throws. So I'm going to go into the specifics of these different tools and the actions there. But I'm going to do that with really short little separate videos for the different tool sets. So just be aware of that. Okay, so the big idea in this is we're setting up a line of rendering with different distances. We're doing little separate either Unity actions or private functions that we're running to basically be run every frame to give us information about the scene. So where do we want the line to be rendered? We want it to, generally speaking, we want it to not be rendered, or to go out to whatever a hit point is that we're hitting on the object that we're aiming at. We need to find out what object we're hitting. We need to get the reticle to go to the right spot on that object. And so the reticle moves out to the hit point, or else it just stays at the origin. When we update the line, it raycasts out on the interactable layer mask to find the right spot to go, and that end position is created by sending that raycast out. And if there is a collider, it's going to return end position as the hit point. And this is setting up the start and the end of the line that's rendered, and it's returning the end position. And as part of that process, it has to create a raycast on the interactable layer. So here is the function that I'm actually calling when I'm here, creating the raycast only targeting the interactable layer. So when we create a raycast, it's returning a hit, which allows us to find out the name of the game object that hit, which allows us to use those weapon actions ifs to target the right action to happen. And then set line color I'm not using, but you may find that useful in some way. The update origin is setting the origin to the correct spot. The update pointer status is setting the raycast and determining the game object again. And then we're into the private process, touchpad down, and all the ifs for the different indices to do different things. Change the weapon as according to the touchpad actions. Change the tool that we're using, and then we go to process to pull. What happens is determined by which index is active. Okay, so there's the summary. That's the end of the explanation for the Pointer script. I'm just going to flip over quickly to the reticle. And so the reticle's script is pretty straightforward. And the reticle object itself in the scene, switch over to Unity, go down a bit. So there's my reticle. Double click on that to focus on it. It's a crosshair system. So what we want to do is basically just switch the graphic for the crosshair when we do. So in the scene, the reticle main object itself has a reticle script. The child object has a sprite renderer on it. The open crosshair is the default sprite. So that's applied to the sprite renderer, and it can scale it either on its import, or you can scale it here to be the size that you want it in the scene. On the reticle script uses the pointer to locate where the reticle should go, and the circle renderer is the base renderer, the very base sprite. The open sprite is the same. The closed sprite is a different one. So for me, again, I'm using this open one to be my open sprite, this closed one with the dot to be the closed one, So basically, you want to indicate through a change of sprite that you are aiming at an object correctly. Okay, so just a quick look at the Reticle script. The Reticle's basic function is to indicate where we're aiming and whether we've hit anything with our raycast forward. In order to do that, it needs a connection. The Reticle script needs a connection to the pointer. We need to target a sprite renderer. When we need to tell it which sprite is the open sprite and which sprite is the closed sprite for when we're aiming at something that we can interact with. And we're using the main camera. We're setting up the main camera so that the transform of the reticle will always be looking towards the main camera. And then that way you're always looking at the reticle based on your view of it. The one kind of tricky thing about it is we are we're adding a delegate function to a main function that was created on the pointer script. So at the player events, we created delegates and added functions to them from the pointer. So on touchpad up, for example, we added to that on the pointer script. So we have this process touchpad up that was created on player events. The actual functionality of it was added onto pointer. In this case, it's just returning. It's kind of the same way on the Reticle script. We're adding in functionality to on pointer update, which is running on the pointer script. So I'm just going to go up to void update. So under void update, if pointer update hasn't already returned, right? If on pointer update returns anything, then on pointer update gives us the hit point in the current object. So it's doing that in sort of cooperation or coordination with the Reticle script in order to have the sprite updated for our pointer. So the sprite gets located in the right position. So on awake, it targets the main camera, and it adds to pointer on pointer update plus equals update sprite. Because this script is attached to the reticle, when it says transform look at main camera, the sprite object itself points its face at the camera, so we're looking at it dead on. On destroy, well, just like all our other delegates, we don't want this listener kind of function to always be running even after our game scene ends, or an object, or this reticle got turned off. We don't want it to be running. So we have void on destroy that turns it off, minus equals to turn it off. And the delegate function is this one, private void update sprite, and it's using a vector3 point, which is the hit point, and it's using a game object. So whatever object our raycast hits, it's identifying that hit object. And so transform position equals point, so it moves the reticle to wherever our update sprite is finding the collision between our raycast and the object that we've hit. If there is a hit object, then it's showing the close sprite. If there is no hit object, then it just leaves it as the open sprite. And that's basically it. So it takes all of these scripts, the player events, the weapon actions, the pointer script, and the reticle, all working together to make it work. And so if we look back at the pointer in my scene right now, all those public variables are filled in. I'm giving them a default distance of 10. I've told it that this object is the line renderer. I've told it that everything in the scene is part of the everything mask. And I've told it that only the interactable layer is part of the interactable mask. I've assigned the reticle to it. I've assigned my gaze pointer to it. So these are, now we're getting into the functions that I've created. So the gaze pointer is part of my menu interaction, so I've assigned that. Grabbed object I have not assigned. I set it as public for testing purposes, but I could make this a private variable and it would still work. It's critical that in my script I've named the object with the list of different tools. I've named it weapon. You can name it something else if you want, but you have to make sure that you assign from your OVR camera rig that you assign the parent object that has the weapon actions script on it. So that's the object, the one that has the weapon actions one on the pointer. That's what you have to assign as weapon. And then I have other objects as part of the child objects for the weapon that become the teleporter object, that become the hand for grabbing. The grab transform is an object position where we want objects to appear when they've been grabbed. So in my scene right now, if I look at my grab hand, there is no object assigned there to be the thing where I want things to be located. So I'm going to do it right now. I'm going to create an empty object and I'm going to move it slightly down from my hand, and I'm going to name that grab transform. So on my pointer script, where it says grab transform, I can say that's where I want objects to move to when I grab them in the scene. And for me, I moved my 3D models around so that the shot origin, where I start the line, whenever I want to have that raycast identified with a line renderer, I've got it set up so that everything can originate with the weapon transform. So all the lines in my scene are starting where my weapon object is located. So if we look at it in pivot local view, the blue handle there is indicating where the lines are going. Okay, so we've gone through pointer, we've gone through weapon actions, we've gone through player events, gone through reticles, so gone through that whole package, and the basic structure has been given. But you'll have to determine which kind of tools you want to use as part of your weapon actions. What I would suggest that you do to begin with is maybe just set it up with a couple of them, maybe the line render, maybe the teleport system, and maybe something to interact with menus, or do a laser. Start with a couple, get used to how the system works, and then you can build onto it. Okay, so that's it for the Pointer and Reticle. I'll be doing shorter individual videos about the individual tools that I'm creating. So bye for now.